Good morning, my dear students. So today in this sessions we are going to learn fifth problem on the wall spring of a petrol engine. Okay. Design a wall spring of a petrol engine for the following operation condition is given in the problem. The spring load when the valve is open, it is given as 400 Newton. So this means that the maximum load is acting on the spring. The maximum load is acting on the spring when the valve is open. How much is given? The maximum load F max is given as 400 Newton. Okay. And the spring load when the valve is closed. So this means that the minimum load is acting on the spring when the valve is closed is given as F minimum equal to 250 Newton. So this maximum inside diameter of the spring, this maximum inside diameter, this is, let us assume this is spring, the maximum inside diameter of this spring di, how much is given here? 25 mm. So it is represented by di, the maximum inside diameter. I is indicate inside diameter of the spring is given as 25 mm. Okay. The length of the spring when the valve is open, the length of this spring when the valve is open, it is given as 40 mm. It is represented by L2. It is represented by L2. Okay. The length of the spring when the valve is closed, it is represented by L1 equal to 50 mm. So the maximum shear stress, the maximum permissible shear stress is given as 400 Newton is given in this problem. Okay. Let us see. If you want to find out the deflection, what is the formula? Deflection equal to L1 minus of L2. L1 is indicate that the length of the spring when the valve is closed. The length of the spring when the valve is closed is given as 50 mm minus L2 is indicate that the length of the spring when the valve is open. The length of the spring when the valve is open is given as 40 mm. If you subtract the value, the length of the spring when the valve is closed is given as 50 minus of 40, then you will get the value of deflection is 10 mm. As well as the maximum permissible shear stress is given as 400 Newton per mm square is given. So in this case, what we need to find out? We need to find out the diameter of the wire. We need to find out in this case. Then so we know very well, if you want to find out the diameter of the wire, then you need to follow the torque formula. Torque, what is the formula? T is equal to maximum force into mean diameter by 2. Maximum force into mean diameter by 2. So T, this value should be equal to how much? Pi by 16. T equal to pi by 16 into maximum permissible shear stress into diameter of the wire cube. Is it right? So already we know very well pi d cube by 60 into shear stress. Is it right? The same formula we need to follow here. F max as it is into mean diameter by 2 as it is equal to pi by 16 into shear stress into d cube. Then the maximum force is acting on the spring when the valve is open. How much is given here? 400 is given here into this inside diameter of the spring is given as, so the mean diameter formula dm, mean diameter equal to inside diameter plus diameter of the wire. Is it right? So we can represent here di plus d as it is. Here by 2 is there, you need to divide by 2 equal to pi by 16 as it is. Maximum permissible shear stress is how much? We know very well. How much is there? 400 is given in the problem. 400 into d cube as it is. 400 into inside diameter di plus d by 2 equal to pi by 16 as it is into 400 into d cube. So in this case 2 ones are 2 8s are, okay, 2 ones are okay dear. So here 2 ones are 2 8s are, then this 400 and this 400 will cancel. The remaining terms will be di inside diameter of the helical spring di plus d, okay, diameter of the wire equal to pi by 8 into d cube, okay dear. Then so di, it is already given in the question. Di is given as 25 mm plus d as it is pi by 8 into d cube. So 25 plus d as it is, if you divide 3, the pi value is how much is there dear? 3.142 by, this is a constant value, 3.142 divided by 8, then you will get the value of 0.3926. How much dear? 0.3926 you will get. It is a d cube value. After that 0.3926 d cube as it is. If this value, if it is moving from this side, this is minus d minus 25 equal to 0. So why I am taking this value? Because if it is not there, because here in this equation d square is not there. If it is d square is not there, you can take as a 0 value. Is it right? Is it right? So this is the 0.3926 d cube as it is only. If it is here, this is the form of ax cube. What is the form here? Ax cube plus bx square plus c into x plus d. D does indicate it is a constant value, d equal to 0. So if you find out with the help of calc, then you can easily get the value of d. D how much you will get here? 4.205 mm. Then you will get the value of d. After the getting the value of d, then again we need to find out the value of spring index. So diameter of the wire by the spring index you need to find out. What is the formula of the spring index? C is equal to capital D by small d. So this capital D is indicate that it is a mean diameter. Okay, so you have to refer this page number 169 from the equation is 12.26 from the design data handbook by Mahadevan. Okay, then you will get this equation. See the spring index C okay dear. Spring index C is equal to mean diameter by small d. So this, how to get this mean diameter, that is important. Let us see over here above di plus d. Di plus d if you add, then you will get the mean diameter. Let us see that this value is how much? D equal to 4.205. Di value is how much is that here? 25 plus 8. If you add 25 plus 4.205, if you add, then you will get the value of 29.205. So this means that dm equal to di plus d. Di value is 25, d value is 4.205. If you add, then you will get the value of mean diameter of the spring index. Okay, dm mean diameter how much is there? 29.205 by small d, how much you got it here? 4.205 mm. If you divide this value, then you will get the value is 6.945. Then you will get the value of spring index. How much you got it here? 6.945. After that, what we need to find out? We need to find out the shear stress. We need to find out with the help of shear stress equation, we can easily get the value of d. Okay, let us see. tau equal to 8 into, this is the maximum force is acting on the spring, into d into k is indicate that it is a Walsh factor. K is the Walsh factor by pi into d cube, already we solved in the previous problem. So if you want to find out this k value, the Walsh factor, the page number 169 you need to follow. K is equal to 4c minus of 1. The c is the spring index. K is equal to 4 into spring index minus of 1 divided by 4 into spring index minus of 4 plus 0.615 by spring index. The 4 as it is, the spring index value is 6.945. okay, the 6 point, okay, no problem, by 6.88 I'm getting plus 0.615 by 6.945 I'm getting. Is it right? After that you will get the value is 1.217 because the small mistakes I did here. Okay, k is equal to 1.27 you will get. After that, the shear stress, this value we need to substitute in this equation. 8 into maximum force into Walsh factors. This, how to get this d by d? D is as it is only. If you remove this one more d from this side, remaining should be, if the bases are same, d square into d. If you add, if the bases are same, the power should be added. 2 plus 1, it should be how much here? D cube only. Is it right? 8f, 8 into f into k divided by pi. I am taking here only d square. Remaining terms should be d only. Here toward should be d only. So d by d, what we can see here, we can see as spring index. What is the formula? C is equal to d by small d, we can say as spring index. We know very well, already we have solved in the previous problem. Tau as it is, tau is how much? Maximum permissible shear stress value is given in the problem is 400 Newton equal to 8 as it is. Maximum force is how much here? 400 into the Walsh factor is given as 1.217. The spring index is given as 6.945 divided by pi into d square. If you cross multiply this equation, it should be how much? D square here, 8 into 400 into 1.217 into 6.945 divided by pi into 400. Then after that, if you remove this square, it is making as the root. After that you will get the value is 4.617 mm. Okay, after the getting of the 4.6 mm, you need to find out the higher order of the wire. Okay, this 4.617 mm, we can take the approximate value 4.62 mm. Is it right? After that we need to find out the mean diameter of the spring. We need to find out. Already we have solved this value. The mean diameter dm is equal to di plus d. Di value how much is there? 25 plus d how much? 4.62. How much will get their mean here? Mean diameter you will get is 29.62 mm. After the getting of the mean diameter 29.6 mm, we need to find out the outer diameter of the coil. We need to find out. If you want to find out the outer diameter of the coil, the formula is outer diameter equal to mean diameter plus coil diameter. Is it right? So the mean diameter how much is there? 29.62. How much? 29.62 plus this diameter of the coil is given as 4.62. If you add 29.62 plus 4.62, then you will get the value is 34.22 mm you will get. After the getting of the outer diameter of the coils, we need to find out the value of I value. If you want to find out the I value, then you have to go for, first of all you need to assume the modulus of rigidity value, because in the number of turns coils, okay, is what is the formula? Y into mod, Y is the deflection, G is indicating the modulus of rigidity, diameter of the coils into the maximum force is acting on the spring, or is it right? Sorry, the minimum force is acting on the spring into spring index. So the Y value, is the deflection already we have solved. Okay now dear, then first of all we need to assume the modulus of rigidity G is equal to how much? 0.07845 into the power of 6 megapascal from the high carbon wire. So we have to refer the table number 11.5, page number 190. Page number 190. The force F is equal to maximum force minus of minimum force. The maximum force of the spring, how much is we got here? 400. The minimum force when the valve is closed, how much is given? 250. 400 minus of 250, then you will get the value of F value. Is it right? Then the Y is the deflection 10. The modulus of rigidity 0.07845 into 10 power of 6 from the, you have to refer this modulus of rigidity from the table number 11.5, page number 190 from the design data handbook. Then you will get the value of G value from the for the high carbon wire. Okay, and D is already we got it. How much? 4.62 divided by 8 into F. F is force is acting on the spring into 150 into this spring index is 6.945 whole cube. If you subtract the, if you divide this value, then you will get the value is 9.27. so it is approximately equal to how many number of turns here? The number of turns should be 10. After that we need to find out the pitch of the spring. We need to find out in this case. If you want to find out the pitch of this spring, then you have to refer the first formula is yellow is the free length equal to yellow is greater than equal to I is a spring index value. Okay, already we have solved. I is the number of turns, how much? 10 turns is will be there, plus 2 into diameter of the wire, plus Y plus A is the clearance. So we know the formula of clearance is A equal to X into D into I. So first of all you have to refer the figure number 11.6, page number 174 from the design data handbook by Mahadevan for C. C is the spring index is given as how much? 6.88, and diameter is greater than equal to how much will be there? 0.8 mm. So X's value is approximately equal to the 0.152. So A equal to clearance is given as X, how much here? 0.152 into, so this D value already we have solved, 4.62, and I is the number of turns. Already we have solved. How much dear? 10 number of turns. Here is there. I is number of turns should be 10. You need to multiply this value 0.152 into 4.62 into 10, then you will get the value of A. Okay, clearance value how much we got here? 7 mm. After the getting of the clearance value, you need to substitute in this equation. So after that, yellow is equal to number of turns should be 10 plus 2 as it is. Diameter of the coil is 4.62 plus Y is 10. Okay, plus A is the clearance. How much we got here? 7 mm. If you add this value, then you will get the value is 72.44 mm. After that, if you're getting the value of 72.44 mm, first of all, after that we have to find out the value of actual number of coil, as well as we need to find out the free length. We need to find out, the main intention is we need to find out the value of pitch of the spring. We need to find out. So after that, if you're getting the value of LO 72.44 mm, first of all you have to refer the table number 11.4, page number 189. Assume square and ground and type D you have to assume. The first of all, the actual number of coil is equal to I is number of the turn plus 2. So this number of the turn is how much will be there here? 10 will be there. 10 plus 2 equal to how much should be? Actual number of coil should be 12 mm. 12, sorry, actual number of the turns should be how much? 12. The solid length equal to the number of the turns I plus 2 into d. I value is the number of turns should be how much here? This is 10 plus 2 should be how much? 12 into diameter is 4.62. If you multiply this term, then you will get the value as 55.44 mm. Free length of the coil is I, the number of the turn, into pitch plus 2 into diameter. LO already we have solved here, 72.44 mm. 72.44 mm equal to the number of the turns should be 10. Pitch we need to find out into P plus 2 into D, how much? 4.62. So if it is moved toward here, 72.44 minus 2 into 4.62 divided by 10, then you will get the value of pitch is 6.32 mm. This is the pitch of the spring. Okay, I hope so no one is having the doubt regarding up to here. If you have the doubt regarding, please write down in the comment box. Please don't forget to subscribe my channel. Thank you dear.